Okay, so here we're doing lesson 3 in functions. We're also going to do lesson 4 right after. We're going to start by talking about functions. Now, functions is a specific kind of relation. So it's a relation that is either one-to-one or many-to-one. Now, say, well, what does that mean? Well, that is for every valid independent variable, so every value of x, there's only one value for the dependent variable. So that means for every value of x, there's only one y. Now, you can have more than one x value for your y, but you can't have the reverse. Okay? So that's a little bit to wrap your head around. So there's one specific test that works to test to see if something is a function. It's called the vertical line test. Now, if a function is graphed, right? So a function can be identified graphically if no matter where you draw a vertical line, you only intersect the relations graph once. That's called the vertical line test. So we're going to do the vertical line test. So using that, if I look at this first one, if I draw a vertical line, which is a straight up and down line through here, what I note is that I cross this function in two places. So this is not a function, okay? And that happens in a number of places. I draw it over here, I cross it twice. So that tells me that when I'm drawing those vertical lines, if it crosses more than once, it is not a function. If I look at this one, you may say, hey, is that a function? Well, okay, if we draw a vertical line here, one thing to note is this point has an open circle. So it technically doesn't actually cross the function. It's not part of the solution set, whereas that one is closed. So this only crosses once. Let's test the other one. A similar thing happens here. Draw it, but this one here, the middle one, has an open circle, so the one in the middle, whereas that one crosses. So those vertical lines technically only cross it once. So yes, this would be a function. Passes the vertical line test. This graph, there's many places I can put my vertical line and it only crosses once. But I have a spot right here. I draw my vertical line, or right here, I draw my vertical line. I have two intersections. So there and there, or here and here. So this would not be a function, okay? Now, we don't always have a picture of a graph, so what we have to do is compare our x values. So, if we have more than two y values for our x, then we know it's not a function. So looking at this, I'm going to highlight if I have x lifted twice. Here and here, x is twice. So I have two possible answers for x. So that means it is not a function. Okay? Doesn't matter about the y values, but it does matter with the x values. And because I'm getting two different connections with it, that means when I graph that at the point of x equals 3, 2, 3, 4, 5, 6, 7, beautiful graph, eh? I would have one at the 5 and one at the 7. So if I drew a vertical line, it would cross in two places, okay? But we don't have a graph, so you can just look at the x values. And if there's more than one y value for that x value, you know it's not a function. So similarly, we look here. Based on this information, we don't have any repeated x values. So based on that, we could say that that is a function. Now, it's hard to tell. There could be other variables involved, but based on what we're given, that is a function. Looking at this last one, I'm going to get rid of this. There we go. I got rid of my ruler. Excellent. We look at our input. Remember, our input is our x values. Okay. So this is our x values. And our output is our y values. Okay. Sorry about my writing. So I don't have any repeated x's. Some of the y's, there might be a crisscross, but that's okay. My x's are not crisscrossed. So these points say that, yes, that could be a function. If I had two of the same values, like if 2 was repeated or -1 was repeated, then, and it matched up with 2 different y's, then yes, then no, it wouldn't be a function. But it's basically as long as the x only has one corresponding value for y, we're okay. Y can have many correspondings for x. Okay? So your assignment is to go through some examples and look and test. Use the vertical line test. Use these values of x to kind of see, is it a function or not? So you're going to do some of that. So you would pause, do that assignment. We're going to look at lesson 4 now. Now, we use a specific kind of notation called function notation. And so our functions can be written as in function notation. And we use the notation y is equal to f of x. Sometimes we use y is equal to g of x or t of x or d of t. But in this model, this general model, y is the output. F is the name of the function. So if I had y is equal to g of x, it would be a different function than y is equal to f of x. Okay? And x is the input. So x is the value I'm changing. And remember, I can only have one output for my input. So I can't have more than one outputs for my values of x. Okay? Oops, look at that. So, sorry about that. So, some examples. We can write this in two different ways. If I'm writing it like this, that's the function. If I were writing it in the function notation, it would be f of x is equal to x minus 2. So what we're seeing here, and I'm going to just kind of highlight it, is that the y is the output, which relates to that f of x. Okay, so the function of x produces that y value. If I wanted to write it, this is a distance time graph. Distance would be here, d of t would be equal to 30t, 30t. You can see what kind of matches up. And in here, I have 12 plus 5, 12 plus 5 here. C, this would be the function c of n. Okay, so the blue is the output. And we're putting in x, t, and n are our input. Okay, so let's do some practice. If I want to translate, so I've got y is equal to 2x minus 1. So I'm going to write these in function notation. So I'm going to say y is equal to f of x, so replace that, is equal to 2x minus 1. It's as simple as that. You can see what has interchanged there, right? I have a different function here. I have s is equal to 8 of t. So s of t is equal to 8t. Okay? So I just basically replace that with that. Okay? Now, it's just another way of notating things. So we're talking in terms of input and output. And that's when we start that. So it's important for you to kind of understand that there's a variety of expressions for it, or ways to express that function. Okay, so let's now see what we can do with functions. One of the things is that we're talking about changing inputs. So given that g of x is equal to 3x minus 1, we're going to evaluate g of x is equal to 2. So what we're saying is g of x is equal to 2. So we're gonna replace g of x with 2. So it will be 2 is equal to 3x minus 1. So to evaluate, we're going to rearrange and solve for x. So I would use my equation skills. I'm going to add 1 to both sides. So I get 3 is equal to 3x. And then I'm going to divide both sides by 3. So after that, x is equal to 1. And that would be my evaluation. We can do, this is solving for the output, right? Or solving for the input. We can also solve for the output. So here, if I'm saying g of 4, what I'm saying is it's equal to 3 times 4 minus 1. And that will be my y value. Okay, so I put the x in for 4. Or 4 in for x. Oops. It's been a long quarter. So 3 times 4 is 12 minus 1. So y is equal to 11. Okay, so in this place, I'm using 4 as the input, putting it in for x, and I'm solving for y. Next one, we have g of 2 of x. So everywhere there was an x, we're going to put in a 2x. So it's going to be y is equal to, and instead of x, we're going to put a 2x minus 1. So it will be 6x minus 1. And I can't really solve it further than that because I still have a variable. So all I did was I replaced x with what's in the brackets. Okay. Okay, so this goes for the next page. Use the diagram to determine each of the following values. So I have a diagram here, and I want to know what h of 8 is. Now remember, this is my dependent variable. So it would be my vertical axis. So what I do is I look at where h equals 8. So h equals 8 right here. So if I draw a line over at h equals 8, it's equivalent to 5. Oh, wait, no. I'm doing that backwards. My goodness. I need where the... Rewind. I'm finding the dependent value. This is like the x, right? Or in this case, this is a t, right? So I find my t on this axis. Please ignore the first 8 there. I'm like doing it thinking this doesn't make sense. So we're dealing with, if I line that up, equals 6. Okay. We want h of t equals 10. So in this case, I find where h of t equals 10. Well, at that point, t equals 0, right? Because it's right on that. So after all this, this is t. T is the independent variable, right? Because this is the horizontal. And h is the dependent variable because it's the vertical. Is it discrete or continuous? Well, the line is solid, so it would be continuous. If it had been discrete points, we would be talking about a discrete, but we have a continuous line there. Okay? Interpreting data graphs. Use the diagram to determine each of the following values. So we're going to look at this and we're going to kind of interpret the information on the graph. You have to read the axes and kind of see what's going on. It says Judy recorded the money she saved in dollars every week for 10 weeks. And then she plotted on a graph the following. And didn't she make a nice graph? Look, it has so many things I love about graphs. It's got a title, saving money. It's got titles on the axes. So she's graphed the amount of money in dollars versus time in weeks. Okay. Now, how much money did she have saved at 9 weeks? So the weeks are down below. So we're going to sketch in, right, at 9 weeks. And we're going to go over here to see how much money she had. So if we line that up, she had $75. Okay. How many weeks did it take to save $50? So we're going to go over here at $50. We look over, and if we go down, it took 4 weeks. And here it says, what is the dependent variable? Well, the dependent variable is on the vertical, right? So it is the amount of money. Weeks don't change, right? So it's got to be independent in dollars, okay? And what is f of 6? So this means that this would be our x value, right? So f of 6 would be 6 would be here. And if we look up, f of 6 would be $60. Okay, so just a matter of reading the graph and realizing what they're asking for when they put it in different terms. Sometimes they may just ask for the number, what's the money at the number of weeks. Sometimes they may put it in function notation. And all that means is if x is equal to 6, then what is the value for the function? Okay? So that's function notation. I know we just got to introduce ourselves to it in this unit. We'll get a little practice. When you encounter it in Math 10, hopefully some of it feels familiar, so it's not all brand new. There's a lot more you'll be learning with regards to function in Math 10, but this is just a little introduction. And you've got some practice that you can do here on function notation to kind of reinforce those skills. Okay?